In this set of notes in 10.4, we're going to go through angles inside of our circle, so it's not the property of chords, sorry about that. So it should be our angles and inscribed angles. So if you notice in here, one of the big ones that I want to make sure you guys copy down is this angle right here is the inscribed angle. So that's because the vertex is on the edge of the circle. So right here, my angle B is on the edge of the circle. And how that measures is that this angle right here is going to be half of the arc degree. So if this is 47 degrees right here, then that means that my arc of A to C is 94 degrees. So you can't really put that on around your circle since you're going to cut it out, but that's why we put it inside the circle as a little example right there. So if you're given this measure, if this was 100, then the inscribed angle would be 50 degrees, so it'd be half of that. This is another one that's going to be very common that's going to show up. And what you have to look at is there are two different angles here. We have this orange one, so EHG, and we also have EFG. All right, so one thing you want to notice is that the two of those are going to be congruent to each other. So if they give us that this outer edge is 90 degrees, the arc length is 90 degrees, notice that they share the same arc. So this would be half of that, which would be 45 degrees. And so would my purple angle. So that's why those two are congruent, is because they share that same arc. This one down here, our picture in the bottom of your circle, is, if you notice, KL is the diameter. So when I make a triangle off of that, since this is my inscribed angle, that means that this is 180 degrees. And if you think about it, that's half of the circle, so that makes sense. So that's why the angle across from it, then, that 90 degrees is going to be half of it. So that actually makes a right triangle whenever the diameter is the hypotenuse in that triangle. For the last circle right here is if we have a four-sided figure, so quadrilateral, that's inscribed in the circle, so that means that all 4 points are touching the edges of the circle, that these opposite angles are going to be supplementary. So my O plus Q should equal 180, and my P plus R should also equal 180. One other little vocab word here is this 94 degrees, that's called the intercepted arc, so it's the angle that's across from that inscribed angle. This is where we're going to use our intercepted arc and our inscribed angle. So this 50 degrees that's right here, the angle that's right there, or the arc from Q to T, is going to be double that. So that will be 100. If this is my 48 for the arc, the angle that is opening up towards that is going to be half of that. So that will be 24 degrees. So my angle T will be my 24 degrees, and my arc QR, which if you notice that that's right here, so we need to do a little more calculations. We already have the 100, but notice this is the diameter, so all of this should equal 180. So if I already have 100, then the leftover part will be 80 degrees. All right, so for number 2, if we look at this picture, if you notice that this angle right here, my blue one, is 31 degrees, so that means across from it, this arc will be 62 degrees because it's across from it. And that means if we take that and now work our way into this other angle, so our angle T, that is going to be half of it. So that's going to be 31 degrees. So what do we notice about angle STR and RUS? In that they are both 31 degrees. So they are congruent to each other. And they share the same arc in the circle. All right, so our picture for number 3, when we look at it, we want to find two pairs of congruent angles in our figure. So let's just look at our picture to begin with. So we should be able to notice that SRP, so angle R right here, should be congruent to my angle Q because they share this arc. So on the flip side of that, if I look at the opposite side, RQ, for the arc of RQ, that means that angle S is going to be congruent to our angle P. So the only one that shows that is the letter C right here, because our PQS is my one in orange, is congruent to my PRS, and that's the one in orange. And then QPR is my one in blue, and then QSR is also my other one in blue. So it pairs up the correct angles together. So in number 4, what you want to be able to do is take any of these degree numbers and work through your triangle to find some different pieces. So first off, if we want to find the red arc or angle, depending which picture we've got, we're looking at the arc in this one for the 90, and that means that we can figure out what this angle is going to be. So angle G will end up being half of 90, so that would give us 45 degrees. So then if I want to start with the angle and I'm getting bigger, I need to multiply my 38 times 2, and we get a 76 degrees, so TV, so the measure of TV is going to be 76 degrees. All right, so then with this 72, if you notice which way it opens, that means that ZV is 72 degrees times 2, because we have to double it for the degree, so that gives us 144 degrees. And then going backwards into the angle, that we have to take half of that. So 144 divided by 2 also gives us the 72 degrees. So my angle X equals 72 degrees. All right, so here's 2 more vocab words right here. If you notice, some of them were, one of these was on the circle that we were writing. So a polygon that has all of its vertices on the circle is called an inscribed polygon. So if you look at it, all of my blue figures right here are inscribed polygons because all of the vertices are touching the edges of the circle. Then on the flip side of that, if you look at just the circle itself, the circle is called the circumscribed circle because the circle contains the vertices. So the part in red is called the circumscribed circle because it's going around our figure and it includes all the vertices. So it kind of depends what part you're talking about. The first one is talking about the polygon itself, so the shape inside the circle. This is talking about the actual circle itself. All right, so remember from our orange circle that if a quadrilateral is inscribed in the circle, so if it's inside the circle with all the vertices touching the edges, then the opposite angles are going to be supplementary. So when we look at that, that tells us then that this 80 and the x are paired up together. So 80 plus x should equal 180. And then thinking of the opposite corners and the other parts, we have 75 then, plus our y should also equal 180. So if I'm going to solve this purple one first, it's going to subtract my 75. So y should equal 105 degrees. Then for my orange one, I can subtract my 80. So I get x equals 100 degrees. So the same works in this next one. We just know that these opposite angles are going to add up to be 180 degrees. So c plus my 2c minus 6 should equal 180. So with this one, I have to combine some like terms together first. So I get 3c minus 6 equals 180. And then I want to add my 6 to both sides. So I get 3c is equal to 186 divided by 3. Sorry, that's a c. My c then should equal 62 degrees. So if I'm going for the opposite corners now, my 8x plus my 10x should equal 180 degrees. Combine my like terms together, so I get 18x equals 180. Divide by my 18, and we get that x equals 10 degrees.